Thresholding is an image processing technique where we convert the grayscale image into a binary image. We have a threshold value. If the pixel matches that particular threshold value, if it is less than the threshold value, then some process will get applied. Otherwise, if it is more than some threshold value, then some other process will be applied. So there are different types of thresholding. First one is binary. Now in binary, let's say if I have a grayscale image, if I will set a threshold value, if the pixel intensity is more than that threshold value, the pixel value will be set to 1, or otherwise it will be set to 0. So that is one example of a simple binary thresholding. The other one is binary invert thresholding. Now, if the pixel in this is the inverse opposite. This is the inverse of binary thresholding. If the pixel intensity is more than t, it is set to 0. Otherwise, if it is less than that particular value, it is set to maximum value. So it is completely the reverse. So now this is one example of binary thresholding, inverse binary thresholding. Or sorry, this is thresholding. This is inverse binary thresholding. Adaptive thresholding. Now adaptive thresholding, here it will consider threshold values for small regions. Now that can be in the form of mean thresholding or Gaussian thresholding. And so in case if there is uneven lighting in the image, all these adaptive mean and adaptive Gaussian thresholding are helpful. Then there is Otsu's thresholding. Now Otsu's method automatically calculates the threshold intensity. It works by finding the threshold value that minimizes the variance within classes. So I can, with the help of thresholding activity, I can count cells, measuring tumor size, calculating the leaf area, detecting number of defects, measuring the object size. All this can be done with the help of thresholding. So with the help of thresholding, I can also label regions and count those regions so that it can lead me to the right number that is being seen. Like for example, the number of cells, the number of let's say WBCs in the blood, or the number of leaves, or counting cells in microscopic images. All these can be done with the help of this thresholding and region labeling concept. I will show one program related to this. So here, if I give one particular threshold value, I'm getting one region. So like this, I can check with different threshold values so that it can reflect the right number of regions, and hence help me to count that. So here I have taken the threshold value as 170, and accordingly threshold is being applied here. I have tried to find connected components depending upon that, calculating the area of each of those. So the largest component area that is received is 445157.5 pixels. Basically, it is referring to the area. Here, pixels is not actually the measure. It's referring to the area.